Hi there, welcome to an introduction to graphics programming in C. Today we're going to use the graphics library called the Tiny Graphics Library, or TIGR for short, and we're going to create a simple game. A simple game, and as a demonstration, the final result will look somewhat like this. It is not perfect, but you know, we tried, so yes. Anyways, we're going to be using Visual Studio. So we're looking at Visual Studio here, and I'm using 2015, I think. You can use another version if you want. We're going to be doing this all in C. But when we create the new project, we can just select the language is Visual C++. And we want a Win32 console application. We can browse. I'm going to put my project in the YouTube, whatever. You can browse for wherever you want to put your project. And then I'm going to call this, let's say, all bounds. And then click OK. So it's going to go through like a mini wizard to ask you things. We want a console application, and we want an empty project, just to make everything simple. And then so we hit finish, and it will create a brand new empty project for us. And now let's create a bunch of, let's say, blank source files just as placeholders. So we obviously have the main file, the main.c file. That's where we can put all of our code. And then we also have TIGR files here. We have the C file and the header file. So it's nice. It's only 2 files. So all you have to do is, technically you can download and save, but what I'm going to do instead is I'm going to copy, this is tigr.c, and I'm going to go into all bounds, and I'm going to add new item, C file. I'm going to call this tigr.c, and I'm going to paste in the contents of that file. So instead of downloading, we now copy paste. Moving on, we want to also copy over the header file, so we do that as well, and we put that in header files instead of source files. And if I right click over it, we could create a new item, header file this time, and again we'll call it tigr.h. And then we can replace the pregnant ones that it puts in the default there. And yeah. So up to this point, it's just been a matter of copy-pasting stuff in. And yeah, we haven't done any real programming yet. That's basically the setup. And if we wanted to, we could, let's say, try out to see if everything works. We could do that by writing in our main file that can include the required library, which is tigr.h, and we do so this code just creates a single screen that is 640 by 480, sorry, a single window that is 640 by 480 pixels, and let's call it, give it a title, Hello World, and flags are 0. And then we want to make the screen, let's say, entirely, I don't know, let's, whatever, let's say this color is. And then we update it. We always have to update it the first time in order to make the window display on the screen, and then finally in order to be responsible, we complete this screen once we're done with it. Yeah, and actually, there. So what this is basically doing is we create a new screen, a new window named screen, which is 640 by 480 pixels, and with a window titled Hello World. And then we clear the screen and we fill it with this color here, and then we update the screen to make it appear. We update the window to make it appear on the screen. Sorry, and then so in order so that our program doesn't close right away, we can wait until the window is closed. That's what this while loop is doing. And then once that window gets closed, we we free the screen, the window data, and clean up, basically. We'd be responsible. So we can try running this by clicking on Mobile Windows Debugger, and we'll notice that this doesn't work, unfortunately. So the reason for that is because you actually need to, so TIGR on Windows uses the Direct 3D9 or something like that library, and we actually need to go into, you right click the project, and then you hit Properties, you go into Linker, you expand it, you hit General, and insert input, and on Additional Dependencies, you want to hit Edit, and then you want to type in d3d9.lib. That's the right library for that TIGR needs. But now if we try this, boom, everything works, and that color was apparently a nice orange color. And I probably hit something, but that window wouldn't close. Anyways, moving on. So now let's try and, do something more advanced. And in this case today, as I mentioned, let's try and create a simple game where I'll show, this is the completed thing, basically. We have a ball that's bouncing around, and we have a paddle. And this game is not perfect, but it does kind of show off some of the more commonly used things of TIGR, and also it kind of shows some math and physics-y things. And as you can see there, the ball kind of passed through the paddle, which is why it isn't perfect, but we tried. So the first thing you want to do is change the color, the background color to white, just because white's a nicer background color. So I'm actually going to create a structure called chords that will contain an integer value of x and y. And just a quick note, I will assume that you understand basic C programming. So if you don't, I recommend you try and learn some just by writing programs for fun, like a math quizzing thing, or you can try implementing different algorithms in C or something like that. But either way, you probably want to have a basic understanding of a language before you try doing graphics programming in it, unless it's one of those graphics only programming languages. Anyways, sorry. So we, as we saw earlier, in that game we want to keep track of the ball, where the ball is and where the paddle is. And in order to do that, I create this chords struct that has an x value and a y value. And so we can do struct chords ball. Or actually, let's start off with just creating the paddle. We'll make the paddle track where the mouse is. So in order to do that, we actually also need to keep track of the mouse. So we now have these two chord struts, and actually we can make it more efficient just by putting a comma there. Anyways, and this over here is the initial setup. Always comment your code. It helps you when you are looking back on it many months or weeks or days or years or hours later. So let's initialize everything. We will keep the paddle at a constant y value of 460, and we'll start it off with an x value of 0. And the mouse will just be 0 as well. And so now what we can do is, while we're in this main loop, we can, clear the screen. And we can I'm going to use the word screen and window interchangeably just because I named this variable screen, so I apologize in advance for the confusion if you get confused. So the first thing we want to do is we want to get the mouse's position. And so we can do that. We're very lucky that TIGR already has a function for that. It's called TIGR mouse. So we pass it the current window and a pointer to where to store, like a pointer to the value where we want the mouse's x value to be in, and that's because if it were a value, just a plain old value, we would not be able to get changes from the function. The function would not be able to change that value. And actually, I just noticed something here. So we have a buttons variable that we can use, but we don't actually need to know about the buttons. So what we can do is just throw variable there, some garbage variable, and look at that. Anyways, so now we have the mouse position. And now we can actually update the paddle to the mouse position. And do paddle.x equals to mouse.x minus, and let's say the paddle is 30 pixels wide. And then so now we have the mouse, and we are updating the paddle to the mouse position. And this is nice and everything, but if we try it, we don't see anything, because we aren't actually drawing the paddle yet. So now let's do that. Yeah, so again, so for rectangles, TIGR has a really nice function called TIGR fill. We'll draw a fill the rectangle, so we pass it the screen, the x value, which is paddle.x, paddle.y, the y value, paddle.y, the width can be 30, the height can be 10, color, let's make it nice red. And so actually at this point, if we run the code, we should be able to see a very small paddle. And so yay, that works, and it moves around with the mouse. However, we notice that we're using the same value in a lot of places, and for the paddle width, so what we can actually do is just create a new variable for that. And this time let's make it slightly wider, let's say 100 and a bit, maybe. Oh no, maybe let's say 80. And that is to make it easier on ourselves. And we can replace all these with pedal width. So now when we try, it should be the same thing. Obviously we have longer paddle now, wider paddle now, but yeah, and I'll move around with the mouse. Yay! Oh, also let's rename the window. It's no longer Hello World, this is now Ball Fence. Cool. Now, let's work on the ball. So we'll add the coordinates of the ball here. Let's start the ball off like right in the middle. So the x is 320, and the y is 240. So it's in the middle, it's 640 by 480. And technically it isn't because the ball has a width and a height. That is actually, yeah, no, that's fine. And so, unfortunately, TIGR does not have a filled circle drawing algorithm. It doesn't have any circle drawing algorithm at all. So we can just implement a very crude one right now. So that will be the center x value, and that will be the center y value. We have the screen because we need it. We have the radius. We have the color of the circle. So these things, we are able to draw a circle. So this algorithm isn't very efficient whatsoever, but, you know, we can just go with it. And I just realized I didn't check that, so fix that. This is because I'm kind of looking off the code that I have on my second screen. Help me, because I would not be able to memorize all this. Actually, I probably could. Given the amount of times I've written this, I probably could, but now, rather not. So, basically what we're doing is we're going around in a square, around the entire boundary of the circle, and we're checking to see if the given coordinates match this circle equation, I guess. And if they do, we calculate the proper location for that given the center of the circles, and then we do the color. And so that's it. Sorry, by the way, TIGR plot allows you to plot just a single pixel of the screen. So now we can, after drawing the paddle, we can scroll down and say, draw the ball. We aren't going to move the ball yet, we're just going to draw it. Moving the ball is hard. And ball x, ball y, radius, let's give the radius of 13, and we will color it black. Now if we try it, we should see a ball in the center. There we go. Ball isn't moving yet, but it's there, which is nice. What? No. Now let's try moving the ball. And this is where things get a little bit more interesting in terms of the math part behind it. So we'll give the ball an angle, and every frame will move the ball by that certain amount of angle. And so when we do that, we actually need to keep track of how many frames we're throwing at the screen per second, because if our physics is based on the amount of frames that has happened, let's say we have one frame that's rendered really slowly, and then what that would mean is that the physics would go really slowly in that frame. Then let's say we have the next 10 frames are really, really fast, and the ball would just move super fast, and you wouldn't be able to keep up. So what we do is we force, let's say 16.66 milliseconds to pass, at least. per frame. And 16.66 milliseconds just so happens, if each frame takes 16.66 milliseconds, just so happens that that's around 60 frames per second. What we can do is, at the end of this loop here, say wait until 16.66 milliseconds have passed. And just comment in case you forget. 60 FPS. So we can say, while last frame, which is the variable we have up here, that we should actually initialize to 0. And actually, so TIGR, yeah. So TIGR actually has a library function. TIGR actually has a function called TIGR time that will return the amount of time that has elapsed since the last call of TIGR time. So what we do is we say last frame equals to TIGR time. The first time we call it equals to 0. So this is the equivalent of saying last frame equals to 0. Anyways, so now over here we say, well, last frame is less than 0.01666. TIGR time returns values in seconds, so in order to have milliseconds, we need to divide by 1,000. Yeah. And so last frame, and we add TIGR, whatever TIGR time returns. And then, so once we have had enough time pass, we reset the counter, and the loop continues onto the next frame. So also, we recently added the ball angle value, and so this value is, let's say, a number of radians, let's say 60 degrees, so that's around 1.072 radians. Yeah, and the ball will move at that angle. So we can, in between here, we can say update the ball's location. And we update the ball's location by ball.x plus equals the sine of the ball angle, and the ball.y plus equal to the cosine of the ball angle. And since the ball angle is in radians, we're fine. So now, So now if this runs, nothing works because I probably messed something up. Give me a second. Well, okay. So, thank you Visual Studio for not telling me when I have unknown functions, but here we have sine and cosine, and these are actually unrecognized functions because we have not yet included the math library. Let's see. So basically, these were returning garbage values, and yeah, and the ball values was getting drawn in a bunch of random spot. Now if we try it, it should work. Actually, it should not work. And the reason for this is that sine and cos are returning really, really small values, and having like less than 1. And so, since we're keeping track of the ball's position with integers, and we're drawing everything in integers, everything ends up rounding down to 0, and so the ball doesn't move at all. In order to fix this, what we can do is we can multiply it by some factor, some speed factor. So now if we try it, the ball moves. Yay! The only problem is, of course, the ball moves off screen in order to be seen for a game. And so now what we want to do is we want to make the ball bounce off of the sidewalls. So what we can do is we can go, before we update the ball's location, we can say we check for collisions with this side. And let's say we check the sides first. Ball.x let's say minus 10 is less than 0, or ball.x is plus 10. So we're just leaving it. So the x and y coordinates of the ball are of it in the center. It's not of it on the edges. So what we want to do is just make it so that the ball bounces. We don't want the center of the ball to touch the sides because then it looks a bit awkward. So we're just going to use a nice value of around 10. So it looks like the ball is bouncing off the wall instead of passing through the wall and then bouncing off of it. And then so if the ball hits the side walls, that is, if its x value goes between 0 and goes less than 0 or greater than 640, which is the width of the window, then we'll say ball angle equals negative ball angle. This essentially makes it look like it's bouncing off the sides. You try that here, ball moves, and it looks like it's bouncing off pretty much. And then we can do that for the top as well. And also the bottom. And what we can do is just say ball angle equals the top p minus ball angle. And we don't have a value for pi for some reason. Well, not certain. Like, we just don't have a value of pi in C normally, so you have to define it yourself. And let's just call it pi 3.1415. It's not that accurate, but it's good enough because we're working with only 5 sig-figs there. So if we try it now, ball bounces, everything looks good. The only issue is, of course, passes right through our paddle. It doesn't do anything when it hits the paddle. So now what we want to do is check for collisions with the paddle. So how we can do that is we're looking if the edge, the bottom edge of the ball is greater than the paddle's y. And then, and at the same time, the top edge of the ball is less than the paddle basically what we're trying to do here is we're trying to make sure that the bottom of the ball is between the top of the paddle and the bottom of the paddle. And actually, since we're adding 13 there and 10 there, we can just simplify through that. And so we know that the y values are good now, and now we want to check for the x values. So we want to do this. Again, we're looking for the edge of the ball, and we want to make sure that it is within the paddle's range. And there we go. So basically this equation, or tests if the ball is within the range of the paddle, or somewhat colliding with the paddle. This is a pretty bad checking algorithm. And so what we do in that case is we say we reflect collect the ball off of the paddle. And we do ball angle equals to pi minus ball angle. Ball. And now if we try it, the ball should be able to bounce off of our paddle. There we go. And it works. Yay. So that's all fun. However, there really is no point to the game right now, because if you miss it, if you miss the ball just bounces off the bottom. So let's say we want to make it so that when the ball hits the bottom, the game is over. So what we can do in this case is, first of all, we prevent the ball from bouncing when it hits the bottom. That's what that code did. And then we say if ball y is greater than 480, just again testing to the bottom. Here we can say, we can clear the screen with, say, a sad blue color, and we can print to the screen. This is a demonstration of a new library function. TIGR print allows you to print things to the screen. T-font is the default font that TIGR comes with, that we can use if we want. And we can display simple game over text on the screen. Of course, we always have to update the screen when we print something, display something to it. And let's say we wait a bit, allow the user to cry about how they, lost. And then, so let's say we wait 4 seconds. And then finally, we click again. So this break over here breaks out of this main while loop. This main game loop. And by breaking out of it, it jumps to here, which is just bringing screen, cleaning up, and saying bye. Now if we try it, allow the ball to bounce down, boom. Game over. 4 seconds later, the game quits. And that's it. And then finally, let's add a few more bells and whistles, I guess. So we can add a bit of randomness. Sometimes, let's say the paddle, the ball may get stuck in an infinite loop where the paddle bounces here, ball goes there, and basically, like, it goes in an infinite loop, like, whoops, that was a bad demonstration. Let's say the ball goes here, paddle goes here, bounce, 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 and it's just stuck in a loop like that. In that case, let's say we want to add a little bit of randomness. Into our program. So what we can do is we include the time header and the standard library, and after doing that we are now able to call the function rand, which generates a random number between 1 and rand max, which is some large number, something like 32,000, I think. No guarantees about that actual exact number. However, before we do that, we need to seed the random number generator. We can do that just by giving it the current time. So now, when the ball bounces off the paddle, what we can do is we can add a small amount of randomness. have, let's say, what I'm doing here is, so we want the value to be, let's say, in the range. Like, it could be positive or negative. Sorry, that's basically what I'm trying to get at. So what we can do is do that. So what this here does is it's picking a random number between rand max divided by 2, negative rand max divided by 2, and positive rand max divided by 2. And yeah, now we have a positive or negative number. And then we can divide that number by the total possible random numbers. So this value right here is something between negative 0.5 and positive 0.5. And then again we divide it by 20 because we just want a small number. We don't want too much. So now if we run it, it might be a bit hard to see sometimes, but it adds a little bit of randomness and prevents infinite loops from happening. Okay, we can play it for a little bit. We can play it for a little bit if we wanted to. And yeah. Moving on. Now let's try something fun. We can make the game harder as the player gets better. So earlier here we kept track of the paddle width, which can help us here. Now let's say we wanted, every time the ball bounces off the paddle, we want to decrease the paddle width. So we can say, obviously we don't want to decrease it to 0, then the player could never, and it would be too hard. But let's say every time the player hits up the ball while the paddle width is greater than 20, it will decrease the paddle width by 6. So the paddle width is 90 right now, and it will go all the way down to some number under 20. You can try it by, we see this is how wide our paddle is now, and it should get thinner. Maybe if we try a few more times, it'll become more obvious. I think that time it was more obvious that the paddle was shrinking. If we wanted to, we could increase the amount it shrinks by to make it even more obvious, but that's fine. We can do that some other time. One last thing that we can try is increasing the ball's speed. So over here, this is essentially the ball's speed, 4 pixels per frame, I guess. And so we can create a new variable for that ball speed. And we can initialize it somewhere in here. Ball speed, let's start it off at 4. And so we'll replace that here. And then increase the ball speed. Let's say if the paddle width is less than or equal to, let's say 60. At that point, we're going to start increase the ball speed. And again, we don't want to increase the ball speed too much though. We'll put an upper limit of 20. We'll just increase the ball speed by 1. Now if we try it, actually if we try it, it'll still take a long time because we need to go from our paddle width of 90 all the way down to something below 60. So what we can do is start off our paddle with something like 60, and we can also make the ball speed increase of, let's say, 3. So let's try this. Boom, you can see that the ball is very clearly moving a lot faster. And it does get pretty hard. And game over there. so we can undo our changes because we don't always want to play like that. There. And now we have our completed game. Okay. And that's really about it. Hopefully you kind of saw how to use some of the functions that are available to you with the TIGR library. Also a little bit of math here. And I will post all the code onto this link here. It's blank right now. And yeah, thanks for paying attention for however long this video is.